Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking, what is the de Broglie wavelength in angstrom of an electron at 100 electron volts? What is the wavelength for electrons at 12k electron volts, which is typical for electron microscopes? Comparing this to visible light, comment on the advantages of an electron microscopes. Okay, now let's look at this one. First, they are asking for the de Broglie wavelength for 100 electron volts. De Broglie wavelength equation is given by lambda is equal to h over p. Here h is the Planck's constant, p is the momentum. Instead of momentum, we can write it as momentum is equal to mass time velocity. So we can write mass time velocity, and velocity for an electron is can be written as square root of 2e divided by m. So 2e divided by m, if we switch this one with this one, because here we have energy provided, that's why we need this form in order to calculate this lambda, because mass of the electron is known, this Planck's constant is known, energy is given, so there's no problem. Now let's go ahead and plug this one right here. So this is going to be h over m. Instead of v, I'm going to plug this one. This is going to be square root of 2e divided by m. And here you can see denominator is square root of m, right? And that square root of m goes to the top. So we are going to have h square root of m, and m can be written as square root of m times square root of m. And here we have 2e. This square root of m, this square root of m cancels, so we can combine these two together. So we will get h divided by square root of 2em. And instead of putting e right here, we can also write it as square root of 2m, like e power negative half. It's the same thing. Now let's go ahead and plug the values. Planck's constant is 6.63 times 10 to the power of negative 34, and we have square root of 2m. 2 times mass of the electron is 9.11 times 10 to the power of minus 31, multiplied by energy. The given energy is 100 electron volts. Now we have to convert electron volts into joule. In order to convert this one, we have to multiply this one by 1.6 times 10 to the power of minus 19 power negative half, because we have a negative half power right here. And if you calculate this one, finally you will end up with 1.23 angstrom. Angstrom is basically 10 to the power of minus 10 meter. So you can like in short form we can write it like that. Okay, so this is the answer for the first one. Now the second one we have is 12k electron volts. Now let's go ahead and calculate that one. It's the same thing. Now I'm going to directly plug this one, because this is the derived equation. We don't have to do this all over again. We can directly put that equation and plug the values. So h over square root of 2m e power negative half. Let's use a different color. Okay, this one is better. So lambda, h is same, 6.63 times 10 to the power of minus 34 divided by square root of 2 m, mass of the electron, that's 9.11 times 10 to the power of minus 11, and multiply by e power negative half. Here the energy is 12k electron volts, so 12,000, k is 1000, so 12,000 multiplied by, we have to convert this one into joule. In order to do that, we have to multiply by 1.6 times 10 to the power of minus 19. So multiply by 1.9 times 10 to the power of minus 9, 1.6 times 10 to the power of minus 19 power negative half. And if you calculate this one, you're going to get 0.112 angstrom. So these are the de Broglie wavelength for these two equations. Now the wavelength of the visible light is about 0.5 micrometer. Visible, let's get rid of, so that's all about this one. Let's get rid of this one. Okay, so wavelength of the visible light is 0.5 micrometer. In angstrom we can say 5000 angstrom. But resolution of the electron microscope is much better, right? Because that one gives much better resolution. So that's the comparison, and that's all about it. I hope this helps. Thanks for watching.